Hope you guys had a great weekend. Here we are, Tuesday. Next week, while I'm thinking of this, next week on Tuesday, I have to be in Little Rock for an appointment with my oncologist. Just a checkup. No, seniors do not stay home tomorrow. Seniors have to take the work keys testing. So you should have had an email on where to go at school. You got to go to school and take the work keys testing tomorrow for seniors. That's one of those graduation requirements. Got to take the work keys. State of Arkansas says all seniors take the work keys. So we're doing that tomorrow. So that'll be done. You'll be ready for graduation. But yeah, you should have had an email from Miss Scott, our principal, on that. And I think West students are going to West, and BHS students are coming here. But you come through the virtual entrance. But anyway, next Tuesday, I have a checkup with my oncologist in Little Rock. So I will have a video for you for class. I'm not going to hold class on Thursday. I want to do that for you for spring break because I want you to get your work done early in the week. I want you to wait till the first weekend of spring break doing your work. So I want you to have your lesson on Tuesday. So I'll have like an ed puzzle or something. So that way I can still count you as present, count your attendance because you went and watched the lesson, even though I wasn't physically here. You'll still have the opportunity to be counted present by watching the ed puzzle lesson. But I will be in Little Rock having a checkup with my oncologist. I had scheduled it during spring break, but he has kids and he decided to take off spring break. So he had to move my appointment up to next week. I was going to do it while we didn't have school. So next week, not in-person class, but you do have a video to watch for class because we're starting a new unit. We're starting rational equations next week. So you'll need to watch that and get your assignment done. But do your assignment early next week. Make your spring break longer than everybody else. All these kids in the building, they don't get out till that Friday evening, right? You guys in virtual could have your work done early in the week and add days to your spring break. How fabulous would that be? A lot of students do it. It's worth your time. All right, let's look at what we have this week. Go to our grade screen as usual just to see what's going on. Let's see, Module 5, we're way past that. Matrices, we had these 4 assignments due. Add and subtract matrices and multiplying by scalars. And let's see, this week, look, there's only one thing due this week. The matrix quiz 2, and then we're starting a new unit. So we're finishing matrices today. Matrix quiz 2. And let's go back and see. There is some other things that we need to learn before that quiz. So if you don't look at these lessons, you may struggle with the quiz. So we're in week 27. We'll open that folder. Properties of matrix addition and scalar multiplication. So we talked about how to do matrix addition. We talked how to do scalar multiplication. But there's a few things we need to get here. One thing is zero matrices. Now, this really is very, very simple if you grasp what they're saying here. All right. Again, what you should be familiar with is that a matrix is a rectangular arrangement of numbers in rows and columns. We've been working it for weeks. I have confidence that you know that. This is a 2x3 matrix. 2 rows, 3 columns. All right. If you need to review any of that, it has links right here on stuff we've learned in the past weeks. All right, let's define what a zero matrix is. Not complicated. Don't make this tough, guys. A 3x3 zero matrix is, guess what? It's a 3x3 matrix full of zeros. A 3x3 zero matrix is a matrix that's 3x3 and is filled with zero. A 2x4 zero matrix is a matrix that has 2 rows, 4 columns, filled with zeros. Filled with zeros. We usually call that O. O. Any zero matrix we usually call O because we call it matrices A or B or whatever we want to name our matrix. But we usually call them O if it's a zero. Right? So 0. And they add the little subscript after to say how big the zero matrix is. This is an O 2x4 because it's 2x4. This is an O 3x3. Filled with zeros. All right, so what happens when we add a zero matrix? I'll bet a lot of you can guess. If I ask what happens when we add a zero matrix to another matrix. If we take the matrix 4, 5, 1, 3, and we add a zero matrix to it, nothing happens, right? It's still just 4, 5, 1, 3 because we added nothing. Check. Yeah. It stays like it was. It's just like what we learned in elementary school. If we have a 7 and we add a 0 to the 7, we still just have a 7. Nothing happens. You still just have what you started with. Adding 0 does nothing, and it works the same with matrices. Matrices are no different. Here's another one. If we add a 0 matrix to negative 2, 3, 4, 8, negative 1, 7, we get negative 2, 3, 4, 8, negative 1, 7. Nothing changes. Nothing changes. This one, I knew you guys could get this. This is not hard, adding 0. So whether you add 0 to the end or add 0 first, it's still A plus 0 equals A. 0 plus A equals A. Here's a good question, though. If we wanted to add a 0 matrix to this matrix, what size does the 0 matrix have to be? This rule still applies. If we're going to add two matrices together, those matrices have to be the same size. You cannot add matrices that are different dimensions. So since this matrix B is 2 rows and 3 columns, the 0 matrix that we add to it has to be a 2 by 3 0 matrix. Has to be the same size. What happens when we add opposite matrices? All right, so if A is 4, 1, negative 6, and 2, then negative A would be negative 4, negative 1, positive 6, negative 2. Well, that kind of makes sense. All the numbers are the same. They've just changed signs. The positive numbers became negative numbers. The negative numbers became positive numbers. Now, guess what happens when we add these together? You have to add corresponding elements. This element is in the position 1, 1. So we have to add it to the position in 1, 1. So 4 plus negative 4. Negative 3 plus 3. 8 plus negative 8. I bet you've got this. 7 plus negative 7. No surprise. Check. Yeah, that's how we get a 0 matrix. If you add the opposite. And that we learned many, many, many years ago also. If you have a number and you add its opposite, if you have 11 and you add negative 11 to it, you get 0. So a lot of these are pretty simple. Look at there. Negative 4, 2, 5. Positive 4, negative 2, negative 5. 1, 3, negative 2. Negative 1, negative 3, positive 2. So we know this is going to be all zeros because you're adding opposites. So in conclusion here, if we take A and add negative A, we get a 0 matrix. If we have negative A and we add the positive A matrix to it, we get a 0 matrix. And it also goes to show that A minus A is going to be a 0 matrix, right? 4 minus 4, 7 minus 7, negative 2 minus negative 2. Exactly. What happens when we multiply a matrix by the scalar number 0? Right? When we multiply a matrix by a scalar, every element, every entry in the matrix is multiplied by the scalar, whatever the scalar is. So if we multiply it by 0, love it, 0 times 5, 0 times 4, 0 times 9, 0 times 1. This is all about the zeros, guys. 0, 0, 0, 0. Because when we multiply by 0, we learned that many years ago as well. This one just has more zeros, right? Because everything's being multiplied by 0. All zeros. So 0 times A equals a zero matrix. So here's kind of summarizes everything we just talked about. If you add 0 to any number, you get the original number. If you add a zero matrix to any matrix, you get the original matrix. If you add a number to its opposite, it'll get 0. If you add a matrix to its opposite matrix, it'll get 0. If you multiply a number times 0, you get 0. If you multiply a matrix by 0, you'll get a zero matrix. All right, so zero matrices are not hard to understand because they work just like regular numbers and 0. Just like regular zeros. All right, let's look at the next lesson we need to check out today. Properties of matrix addition. We looked at how to add matrices, but let's talk about the actual properties because the same properties that work generally in math work with matrices. All right, let's look at the properties of matrix addition. So here are properties that we already know about math. The commutative property of addition, like A plus B is the same as B plus A. We know that 3 plus 5 is the same as 5 plus 3. That's the commutative property addition. We learned that many, many years ago. It works the same with matrices. If you add matrix A to matrix B, that's going to equal the same thing as adding matrix B to matrix A. It's the same either direction. The associative property of addition says if we have A plus B plus C, we can add B and C together first and then add A. And that would be the same thing as if we added A and B together first and then added C. And it works exactly the same for a matrix. If we're adding 3 different matrices together, it doesn't matter which 2 you add together first. It ends up the same answer. The additive identity property. For any matrix A, there's a unique matrix 0, a 0 matrix, so that A plus the 0 matrix equals A. So for every matrix, we can add a 0 matrix to it, and nothing changes. The additive inverse. So that says for each matrix A, there's the unique matrix negative A, so that when you add those together, you get 0. You get a 0 matrix because all the numbers are the same, just opposite signs. And then the closure property of addition. A plus B is a matrix of the same dimensions as A and B. If A is a 2 by 3 matrix and B is a 2 by 3 matrix, when you add them together, you get a 2 by 3 matrix. If A is a 1 by 4 matrix and B is a 1 by 4 matrix, when you add them together, you get a 1 by 4 matrix as an answer. That's the closure property. There's no way you can add a 2 by 2 matrix to a 2 by 2 matrix and end up with a 3 by 1. That doesn't work. The closure property says you have to end up with the same thing you started with. And you can only add matrices together that have the same dimensions. So this gives a little more detail about all of these properties. Matrices and matrix addition. So if you have 2 matrices of the same dimensions, you add them together, right? 3 plus 5, because you have to add the same corresponding elements. This is the first row, first column element. This is the first row, first column element. So you add them together, 3 plus 5. First row, second column element added to the first row, second column element of the other matrix, 7 plus 2. 2 plus 8, 4 plus 1. And you end up with 8, 9, 10, 5. So if this is new, then you need to go back and look at these lessons that we did previously. If you're like, wow, I didn't know that's how that worked, you missed something. You need to go back, click on this, and go back to those links. Notice that the sum of 2 by 2 matrices is a 2 by 2 matrix. So we were just talking about the closure property. If you add 2 matrices together, they have to be the same dimensions, and the answer will be the same dimensions as the 2 matrices. So that's talking about the closure property. If the dimensions of 2 matrices are not the same, addition is not defined. You can't add them together. See, this is a 2 by 3, and this is a 2 by 2. They cannot be added. It's undefined. There's no solution to that. All right. matrix addition and real number addition. It works the same way. A plus B is B plus A. 3 plus 5 equals 5 plus 3. And if you add this matrix to this matrix, we could do it in the opposite order and get the same answer. Say it's the same as 5, 2, 8, 1 plus 3, 7, 2, 4. Either way. There's that associative property where we said if you have three numbers added together, 2 plus 3 plus 5, we can add 2 plus 3, which is 5, and add another 5, and it's 10. Or we could add 3 plus 5, which is 8, and add 2, and that's 10. Either way, it's the same way. Same thing with a matrix. If we're adding three matrices together, we can add the first two together and get an answer. Or we can add the second two together first, and we'll get the same answer when we add them all three together. It's the same. The additive identity. If we add 0, we'll get the same matrix. If we put 0 first and add a matrix to it, we'll get the same matrix. The additive inverse. So this is just going into more detail than what we said right at the beginning. If A is this matrix, then negative A is this matrix. Same numbers, opposite signs. These are negative, they're positive over here. These are positive, they're negative over here. And when we add them together, we get a 0 matrix of the same size. All right. And then they have some. We won't do these check your understands. I think you got this. Well, let's do one or two. Let's see. Which of the following is equivalent to this? If we had A plus B in parentheses and add C to it, that would be the same as, oh, wait a minute. This says all answers. So there's more than one. We do need to do this. All right. In the chat, tell me what is the same as this up here. If we take A plus B in parentheses and add C to it, we'll get the same answer as which of these? And there's more than one correct answer. More than one correct answer. I'll give you a chance to look at those. Because your quiz this week has questions similar to this. Bethany said that's the same as C. If we add A and B together and then add C. Is there any others that's correct, though? Because it says choose all answers. Logan says it's the same as this one. But we can add B and C together first and then add A. So A and C. Is it A and C? And is there any other that are equivalent? Does B and D also work? Bethany says D does not work. A plus C plus B plus C. And if you're not sure, just put together a real life example. In fact, let's do this. If you're looking at this and you're confused, pretend they're not matrices, that they're just numbers. And let's look at it this way. Okay, so it said, turn my light on, we can see this a little bit. It said that we could do this, 2 plus 5, which is 7, and it would be 14. So our choices were, what if we took 2 plus 5 plus 7? Right, I just put numbers in for A, B, and C. So that first choice, A plus B plus C, would be this right here. A plus B plus C. So B plus C would be 12. So if we add those together, well, that's the same. So we know that A is correct. What about C plus A plus B? And C plus A is done first. Okay, so C is 7 plus A. Is that going to be the same? And we did C plus A first. 9 plus 5. Do we get the same answer? Look at there. We could rearrange them and still get the same answer. So that worked. How about A plus B plus C? That's real simple. We just take 2 plus 5 plus 7. 2 plus 5 plus 7, that's 14. So C works. We got C checked. A plus C plus B plus C. Well, C. So 2 plus 7 plus 5 plus 7. Right? That's A plus C plus B plus C. Well, 2 plus 7 is 9. 5 plus 7 is 12. And if we add those together, no, that is not the same. All the others equal 14. But when we add, because we're adding C twice, C gets put in there twice. But all these others end up exactly the same. So that's one way you can test that is just actually put numbers in there for A, B, and C. Not D. Check. Correct. All three of those are the same as doing A plus B in parentheses and adding C. Nice. Ooh, now this one gets a little tricky. A plus negative A in parentheses plus B. That's the same as which of these? Is that the same as just B by itself? Is that the same as adding negative A to B and then adding that to A? It says, by the way, A and B are 2 by 2 matrices. These are all 2 by 2 matrices. So is this the same as just taking a 2 by 2 zero matrix and adding it to B? Or a 3 by 2 matrix and add to B? This was a good one. If you can do this, you can do the quiz. If you can't do this, you may need to look a little harder. Check out more examples. Well, what do we know? What do we get when we take A and add negative A? We talked about that up higher in the lesson. If we add A to negative A, Bethany says A, C, and D possibly. She's not sure, but she thinks maybe A, C, and D. If we take A and add negative A to it, that's going to be a zero matrix, right? That's like taking 7 and adding negative 7. It's going to be zeros. That's going to be a matrix of all zeros. And since A and B are 2 by 2 matrices, Sean's caught on to something. He says it can't be D because this is not a 2 by 2 matrix. We can't add it to B because it says B is a 2 by 2 matrix. So D is eliminated. This is a 2 by 2 matrix, and that's what A plus negative A added together would be. So that's the same. Very good. And if we add a zero matrix to B, we end up with just B, so that's got to be right. But the question is this one. A plus negative A plus B. Okay, so I would say let's look at another example with just letters. Now, we already said it's basically like 0 plus B, which is just B. So let's assign values. Let's say A is 8 and B is 5, which means negative A would be negative 8. Right? So the original problem said 8 plus negative 8 plus 5. A plus negative A plus B. Well, that would just be 5 because 8 plus negative 8 is 0. But what about this? So A was 8 plus parentheses negative 8 plus 5. Ended up just 5. So does this end up just 5? Negative 8 plus 5 is negative 3. 8 plus negative 3. Hey, that's also 5. That's just adding 3 things together and changing the order we add them in. So that tells us that's the same thing as well. It's just rearranging the parentheses. 3 things being added together. Instead of adding the first 2 together, we add the second and third one together first. Let's check that. That's it. They all work except for D because it's the wrong size. And that's the end of that lesson. See, is there another lesson? One last lesson. This is it. Then we have the quiz, and we'll look at the quiz before we take off here. Quiz is a little more complicated this time than the first one because we're getting into these properties. Do we understand the properties? Okay, let's talk about the properties of matrix scalar multiplication. Again, the properties. We've done scalar multiplication, but let's talk about the properties. There's the associative property of multiplication. It says if you multiply C times D times A, you could multiply C times D first and then multiply it by A, or you can multiply D times A first and then multiply it by C. Doesn't matter. 2 times 3 times 4, you can take 2 times 3 first and then multiply it by 4. Or you can take 3 times 4 first and multiply it by 2. Either way, you'll get the same answer. The distributive properties, right? If we have a parentheses with a number outside, we have to distribute that parentheses. C times A plus B is the same as C times A plus C times B. We know that. We've used the distributive property for several years. Also, if we have C plus D in parentheses with the number after it, it works exactly the same. CA plus DA. Makes no difference whether you put the number after the parentheses or in front of the parentheses. You just distribute it to both terms inside. The multiplicative identity property. That means if you multiply something by 1, you end up with what you started with. 1 times A is A. 1 times 41 is 41. We know that. It works the same with a matrix. If we take 1 times a matrix, we'll get the matrix. Nothing changes. Multiplicative properties of 0. We just talked about this one. 0 times a matrix will be a 0 matrix. Or scalar, any number, a scalar number, 7 times a 0 matrix will still be a 0 matrix. And then the closure property of multiplication, C times A is a matrix of the same dimensions as A. So if A is a 3 by 4 matrix and we multiply it by a number, the number 2 times this 3 by 4, our answer will be a 3 by 4 matrix. It does not change the dimensions of the matrix. So, more detail. Matrices and scalar multiplication. So if we have a 2 times this matrix, it's just 2 times each number inside the matrix. 2 times 5, 2 times 2, 2 times 3, 2 times 1. So we end up with 10, 4, 6, and 2. Right? If that confuses you, go back to the multiplying matrices by scalars lesson that we did last week. Maybe you haven't done last week's. Maybe why that would be confusing to you. But we've did this the past week. Dimensions considerations. Notice that a scalar, which means just a number, multiplied by a 2 by 2 matrix, is a 2 by 2 matrix. It does not change the size of the matrix. So in general, a scalar multiple of a matrix will be another matrix that has the same dimensions. That's what's meant by the closure property. The closure property. Matrix scalar multiplication and real number multiplication. Okay, let's look at those individually. C times D multiplied by matrix A is the same as C times D times matrix A. So if a matrix is multiplied by 2 scalars, you can multiply the scalars together first if you want, or you can multiply it by 1 scalar and then the other. So let's look at both cases. We have a scalar of 2, we have a scalar of 3, and we have a matrix. C times D times A. Let's say we multiply the 2 scalars together first. We're going to multiply 2 times 3 together first. So that'd be 6. 6 times 5 is 30. 6 times 4 is 24. Over here, we said we're going to multiply the 3 times the matrix first. So 2 times 3 times 5. 3 times 5 is 15. So 2 times 15 is 30. Well, 30 is what we got over here. Look, it's the same. 2 times 3 times 5. 2 times 3 times 5. 2 times 3 times 4 is the same as 2 times 3 times 4. It's the same. It doesn't matter if you multiply the scalars together first or if you multiply them individually. So it's the same. Distributive. If we have something outside the parentheses, we distribute it to each term inside. So if you have C and you have the matrix A and B being added together, we can add them together first and then multiply them by 2. Or we can multiply 2 times each of them and then add them together. But either way, look, we end up with the same thing. 2 times 5 plus 3, or 2 times 5 plus 2 times 3. This is 16. This is 16. It works the same either way. All right, so those equal each other. That's the same thing. Here's an example where C equals 2, D equals 3, and this is our matrix. They work another one to show it still ends up with the same numbers. Here's the multiplicative identity property. 1 times a matrix equals a matrix. Yep. If we have a matrix that's 2, 5, 1, 7, and we multiply it by 1, that's 1 times 2, 1 times 5, 1 times 1, 1 times 7. We still end up with the same thing. That we understood. We've understood that for many years too. 1 times a number equals the number. And then the 0, we talked about multiplying by 0. You end up with a 0 matrix. When you multiply anything by 0, you get 0. So I won't spend a lot of time on that. Let's look at this one. Which of these, it says all answers, which means there may be more than one, is equivalent to C times parentheses 1A plus B. C times 1A plus B. So there's a lot going on. First, matrix A is being multiplied by 1. And then it's being added to matrix B. And then after all that's done, it's being multiplied by the scalar number C. So which of these, all that apply, could be all three, would be the same thing? Can we take 1 times the matrix A and then multiply it by C and then add matrix B to it and get the same answer? Can we just take C times A and add it to C times B? And if we could do that, can we take C times B and add it to C plus A? This is our last one we're checking, guys. A, B, and C, which are equivalent? You can take a guess if you don't know. Bethany says both B and C are correct. See if anyone else agrees. I'll go ahead and mark those. We'll see if anyone else agrees with that. But A didn't work, Bethany?
No, it didn't work because they didn't move the C for the B. They just had B by itself, but the C has to go with the B.
Ah, very good. The distributive property says C is going to be multiplied by everything that's inside. So in A, the C is multiplied times 1A, but it was not distributed to the B. Ah, very good. A does not work. That's correct. So 1A, we know that's just multiplying matrix A by 1. So we can ignore the 1. It's like having 1x. We can just say x, right? We don't have to write the coefficient if it's 1. So this is really just C times A plus B, which is what B shows exactly. C times A plus C times B. But we also know with the associative property, if you can add 2 plus 3, you can also add 3 plus 2 and get the same answer. Very good. That's absolutely correct. All right. So if you want to come back and do the others, there's one that we didn't do. But let's look at the assignment because we've gone through everything. Our assignment is a quiz and it's on Buzz. There are 4 problems. 4 problems here. Oh, it starts out with A, B, and C. If A, B, and C are all 3x3 matrices, and the matrix 0 is a 3x3 zero matrix, which of these is false? Oh, trying to trick you there. Which of those is false? All right. So you got to go through 5 different cases, or 4 cases, really. A, B, and C are either identity or zero matrices. Which of these matrices must be identity matrices? Identity matrices are ones, right? Identity matrix means I'm multiplied by 1. So it'd be a 1, 1, 1, 1. So which of these, A, B, or C, which of those has to be a 1 for this to equal that? There's a scalar multiplication. If X is a scalar number, if X is a number, let's say X equals 5, does 5 times negative 3 equals 6.6? Does 5 times negative 9 equal? So it's not 5. Type whatever number X has to be for this to be true. And then here's another one of those where A and B are 2 by 2. C is a scalar, which is equivalent to this. C 0A plus B. All right, 4 questions, guys. 4 questions. And that's it. That's all we have this week. Then we'll be done with matrices. Next week, we're going to get started with rational expressions, rational equations. I think, what did it say there? Rational equations. So we'll start that. Reminder, I'll have a video posted for you to watch next week because I'm going to be in Little Rock at an appointment. So I'm not going to have class next Thursday. Not mandatory. I will have class Thursday for anyone that needs help or for anyone who grades below 70. But finish these matrices strong. If you're still missing some of these matrix assignments, man, people have raised their grades. I've seen 4 out of 4, 4 out of 4 all day long on this. In all of my Algebra II classes, people are getting 20s. If you don't get 4 out of 4, go back and redo it. Look and see, what did I mess up? Oh, I knew that. These matrices aren't that hard. You should be able to get 4 out of 4. If you're having trouble getting 4 out of 4, come see me. Say, Mr. Brock, I'm going to get 2 out of 4 on this one. I keep messing something up. This should be easy grade boosters. And I see a lot of 20s across the board. A lot of 20s. Not many people are the people that this is not helping the grades, or the people hadn't turned it in. I see a lot of zeros. People haven't done these. So get these done. Get these caught up. You want spring break to be here. Spring break is so much better when you don't have a bunch of work you haven't turned in. Oh, you can enjoy yourself so much more when you know all my work's turned in. I'm just going to chill. Just have a good time. All right. We'll see you guys. Have a great week. I'll be here Thursday.